This was in answer to some questions about how to set up a graph when you have two data sets that have very different scales. So the problem that you'd been asked to work on was one for revenue and marginal revenue. So first of all, we've seen what revenue is. Revenue is the money coming in. Marginal revenue is measuring what happens if you increase the production by 1 unit. So if you create one more item, what will happen to the revenue? That is kind of what the marginal revenue does. And so it would measure if a production of an extra item would give you a little bit more revenue, a lot more revenue, or it might be a decrease in revenue. But before we get to the graph, let's fill in the data sets here. So we will have for the revenue function that this is equal to -2 times my variable squared, and then plus 6 times the variable plus 50. That's minus 210. The marginal revenue is equal to -4 multiplied by the variable and then plus 6. We can do our quick fill all the way down the table. And in order to get a graph, I would highlight everything, then go to plot. I would use a smooth marked scatter for this one. And notice that the revenue and the marginal revenue are both on the same scale. Notice that the revenue kind of shows up like a nice parabola. The marginal revenue is a straight line, but it doesn't really show a whole lot of variation. So if you want to plot this on a different axis, you can do that. You can highlight this. And so once you have selected the data set, you can go to Format, and it says that we're looking at the series marginal revenue, which is exactly what we want to look at. You can format that selection, and if you go to Axis, there's something called a secondary axis. We hit OK. Notice that now it is a much nicer drawn straight line. And remember, we know that the marginal revenue is on the secondary axis. So the area here to the right, this part here, that is the scale for the red graph. So the marginal revenue is plotted for points between -40 and 50. The blue graph is using the old scale, and so it is being plotted for y values between -250 and 100. So they are really two different graphs on two different scales, and this is really then giving you a little bit more detailed information. This is sometimes useful if when you're having something like the red line here kind of squished together too much, it can hide certain features of the graph. So this is why we sometimes graph functions on two different scales, two different axes.